In our first class, we have studied some basic electrical terms in which we have studied what is a sine wave and some electrical terms used about AC fundamentals. Okay, now I just rewind the small terms in that. That is, what is a sine wave? A sine wave is a waveform, that is the value of an alternating voltage or current at any particular instant is called at any particular instant or can be represented as a sinusoidal waveform. So we can represent voltage or current as a sine wave, and at a particular instant the value of that voltage or current can be determined from this waveform. So the value of an alternating quantity at any particular instant can be, if it is a voltage, V or E. We use V or E to represent voltage. So at a particular instant, we can represent it as V of t or E of t. E of t. Represent. Then the particular, if this is a particular instant, what will be the magnitude of that voltage? That can be find out from this waveform representation. Okay, at a particular instant the value of voltage will be this much. Okay, and peak value means that is instantaneous value. We have peak value, peak value can be represented as the maximum value that can be, this is the maximum value. Okay, maximum that value that can be attained by an alternating voltage or current is called peak value. And the average value means it is arithmetical average of all the values of an alternating quantity, that is positive and negative. Okay, so it can be represented as E average or I average. And RMS value is the effective value. And it is defined as the steady current which when flowing through a given resistance for a given time which produces the same amount of heat as produced by alternating current when flowing through a same resistance. That means RMS value means consider a resistor R. When we flow a alternating current through it, if assume there is a steady current which flows through it, it produces the same heating effect on this resistance, then this magnitude of this steady current will give the RMS value of this particular AC waveform. Okay, so that is RMS value, VRMS or IRMS. The value of that will be this much. And form factor is, these are the two factors which is used on design purpose of some electrical machines, and also we should know the factors. Form factor is the ratio of RMS value to average value, and peak factor is maximum value to RMS value. Okay, so now we are going to study about phase of a sine wave. Okay, what is phase of a sine wave? So phase of a sine wave is an angular measurement. നമ്മൾ ഒരു സൈൻ വേവിനെ റെപ്രസെന്റ് ചെയ്യുന്നത് ഒരു വേവ് ഫോം ആണെങ്കിൽ നമ്മളിങ്ങനെ റെഫറൻസ് ചെയ്യുന്നല്ലേ, ഇങ്ങനെയല്ലേ റെപ്രസെന്റ് ചെയ്യുക, വിത്ത് റെസ്പെക്ട് ടു ടൈം ആൻഡ് ദ മാഗ്നിറ്റ്യൂഡ് ഓഫ് വോൾട്ടേജ് ഓർ കറന്റ് is represented on y-axis. Okay, the phase of a sine wave is an angular measurement that specifies the position of sine wave relative to a reference. So first consider a reference wave, and phase of a particular sine wave is relating to that reference waveform. Okay, so first we consider this is a reference waveform. Okay, that is omega t, angular frequency. So just consider omega t on x-axis and v. Omega is angular frequency. Okay, so consider the reference wave which starts from origin. This is our reference wave. We are going to compare our particular wave with respect to this reference wave. ഒരു സൈൻ വേവ് റെഫറൻസ് വേവുമായിട്ട് ഉണ്ടാക്കുന്ന ആംഗുലർ ഡിഫറൻസിനെയാണ് നമ്മൾ ഫേസ് ഓഫ് എ സൈൻ വേവ് എന്ന് പറയുന്നത്. വി ആർ കമ്പയറിങ് എ പെർട്ടിക്കുലർ വേവ് വിത്ത് റെഫറൻസ് വേവ്. സോ ദിസ് വൈറ്റ് വേവ് റെഫറൻസ് വേവ് ആണ് കേട്ടോ. ഇനി ഞാനൊരു റെഡ് വേവ് വരയ്ക്കാൻ പോകണം. When this is 0 and this 90 degree, then 180, 270, 360 അങ്ങനെയാണ്. So from 90 degree I'm representing another wave. So we are representing a wave like this. Okay. So this wave goes through 90 degree. Okay. Just mark it as B. And this one is A. Okay. A is the reference wave. So we can say that the wave B is lagging behind A by 90 degree. So നമ്മുടെ റെഫറൻസ് ഇതാണ് നമ്മുടെ റെഫറൻസ് വേവ് എന്ന് പറയുന്നത്. റെഫറൻസ് വേവ് വിൽ സ്റ്റാർട്ട് ഫ്രം അവർ സീറോ origin. So the positive value from the origin, then it completes one cycle by 360 degree. So when we compare a particular wave with respect to reference wave, what is the phase difference between these two will represent the phase angle or phase difference between these two. That is phase of a sine wave. So phase of a sine wave is an angular measurement that specifies the position of sine wave relative to the reference. നമ്മൾ റെഫറൻസ് വേവുമായിട്ട് കമ്പയർ ചെയ്ത് അടുത്ത് നമ്മുടെ പർട്ടിക്കുലർ വേവിന്റെ പൊസിഷനെയാണ് ഫേസ് എന്ന് പറയുന്നത്. സോ ഇവിടെ ഫേസ് ഡിഫറൻസ് ബിറ്റ്വീൻ എ ആൻഡ് ബി എന്ന് പറയുന്നത് എന്താണ്? 90 ഡിഗ്രി ആണ്. ഓക്കെ. ആൻഡ് another one I will represent here. Just representing E and T, and this is our reference wave. Okay. Now one wave which is passing through the same way. So this one is reference wave. Okay. This one wave A, and another one which is going through 90 degree. Okay. That is wave B. Okay. Then what is the phase difference between the reference wave and wave A? The wave A will be in phase with the reference wave. In phase with reference wave. Because a waveform A and reference wave are starting from the origin at the same time. The magnitude or amplitude of that wave is different from the reference wave. Reference wave in the peak value അതുപോലെ ആംപ്ലിറ്റ്യൂഡ് ഓഫ് വേവ് ഫോം എയും ഡിഫറെൻ്റ് ആണ്, ബട്ട് ബോത്ത് ആർ ഇൻ ഫേസ് എന്നാണ് പറയാം. സോ വി സേ വേവ് ഫോം എ ഈസ് ഇൻ ഫേസ് വിത്ത് റെഫറൻസ് വേവ്. ആൻഡ് വാട്ട് ഇസ് ദ കണ്ടീഷൻ ഓഫ് വേവ് ബി? വേവ് ഫോം ബി ഈസ് റൈറ്റിലോട്ട് ഷിഫ്റ്റ് ചെയ്താണ് ഇരിക്കുന്നത് അല്ലേ, ബൈ 90 ഡിഗ്രി. സോ വേവ് ഫോം ബി ഈസ് ലാഗിങ് ബിഹൈൻഡ്. ലാഗിങ് അതായത് നമ്മുടെ റെഫറൻസ് വേവ് സ്റ്റാർട്ട് ചെയ്ത് 90 ഡിഗ്രി കഴിഞ്ഞിട്ടാണ് നമ്മുടെ വേവ് ബി സ്റ്റാർട്ട് ചെയ്തിരിക്കുന്നത്. സോ ഇറ്റ് ഇസ് ലാഗിങ് ബിഹൈൻഡ് റെഫറൻസ് വേവ്, ബിഹൈൻഡ് റെഫറൻസ് വേവ് ബൈ 90 ഡിഗ്രി എന്നാണ് പറയുന്നത്. ഓക്കെ. ഇനി വാട്ട് ഇസ് ദ ഫേസ് ഡിഫറൻസ് ബിറ്റ്വീൻ എ ആൻഡ് ബി? A and B have a phase difference. Phase difference of A and B are, what is the phase difference? That is also 90 degree. Because A എന്ന് പറയുന്ന റെഫറൻസ് വേവിന് ഇൻ ഫേസ് ആണ്, എയിൽ നിന്ന് 90 ഡിഗ്രി ലാഗ് ചെയ്തിട്ടാണ് ബി ഉള്ളത്. സോ വിത്ത് റെസ്പെക്ട് ടു എ, ലാഗിങ് ബിഹൈൻഡ് എ ബൈ 90 ഡിഗ്രി. വേവ് ഫോം ബി ഇസ് ലാഗിങ് ബിഹൈൻഡ് എ ബൈ 90 ഡിഗ്രി. ഓക്കെ. ഇനി another example, I will show you another example. Okay. First you consider a waveform A. This one is A. Okay. and second one which starts from minus 90 degree here, sorry 90 degree, okay, here 0, 90, okay, so here waveform A is in phase with the reference wave and waveform B is, what is the condition for waveform? This one is waveform B. Okay. So B is leading by 90 degree. Leading. If the waveform is shifted to left side of the reference wave, then we call it as leading waveform. B leading by 90 degree. 90 degree. Okay. So we can say the waveform B is leading the waveform A by 90 degree. Okay. ഇനി വേറൊരു എക്സാമ്പിൾ വരയ്ക്കാം. This is the reference wave. Okay. Then from 45 degree, another wave starts. Okay. The first one is A and second one is B. What will be the A is in phase with the reference wave and we can say B is lagging the reference wave by 45 degree. Right ലോട്ട് shift ചെയ്തിട്ടുള്ള angle ഇരിക്കുന്നത്. So we can say the waveform B is lagging behind the reference wave by 45 degree. Okay. And the what is the phase difference between A and B? A waveform and B waveform തമ്മിലുള്ള phase difference എന്താണ്? Phase difference is equal to 45 degree. Okay. So another one. I will so I here drawing another waveform. A waveform starts at 30 degree. Okay. And another waveform starts from 90 degree, minus 90 degree യിൽ നിന്ന് തുടങ്ങുന്ന ഒരു വേവും കൂടെ കൺസിഡർ ചെയ്യാം. നോക്കാം. ഇത് ഒറിജിനിൽ നിന്ന് minus 90 ഡിഗ്രിയിലാണ് waveform A start ചെയ്തിരിക്കുന്നത്. This one take it as A and this one take it as B. Waveform B. So here you can see reference wave നിങ്ങൾക്ക് അറിയാലോ, അത് ഞാൻ വെറുതെ ഡോട്ടഡ് ആയിട്ട്. This is our reference wave. Okay. So reference wave in the 90 degree ലെഫ്റ്റിലോട്ട് ഷിഫ്റ്റ് ചെയ്താണ് waveform A ഇരിക്കുന്നത്. So we can say A is leading reference wave by 90 degree എന്ന് പറയാം. And what is the condition of B? B is shifted to right by 30 degree. That means B is lagging reference wave by 30 degree. And what is the phase difference between A and B? Between A and B, phase difference is, to the left it is 90, here to the 30. So total phase difference is 90 plus 30. So total phase difference between A and B is 120 degree. അങ്ങനെയാണ് കാൽക്കുലേറ്റ് ചെയ്യുന്നത്. So this is the phase of a sine wave. Phase of a sine wave എന്ന് പറഞ്ഞാൽ it is the angular measurement relative to the reference waveform. So we can find out the phase difference between two waveforms by comparing with the reference waveform or by comparing with respect to each other. Okay. Now angular relations can be represented by, okay, before going to Phasor diagram I will represent. We know that we represent a sinusoidal waveform in terms of and in degrees, that is 0, here it is 90, here it is 180, then 270, and up to here it is 360 degree. In degrees we represent angular relations like this, and in radians you may represent it as, in smaller classes you may study 0, mathematics pi by 2, and this one is 180 degree in radians it is pi, and this one is 3 pi by 2, and this one is 2 pi. Okay, so this is the in radians represent ചെയ്യുന്നതാണിത്. Okay, this in degrees. Okay, so now we can represent this sinusoidal waveform in terms of Phasor diagram. Phasor diagram എന്ന് വെച്ചാൽ നമ്മളിപ്പോൾ സൈൻ വേവ് ആയിട്ടാണ് നമ്മൾ ഓൾട്ടർനേറ്റിംഗ് കറണ്ട് ഓർ വോൾട്ടേജിനെ റെപ്രസെന്റ് ചെയ്യുന്നത്, അതിന്റെ വാല്യൂസിന്. ഇനി ഫേസർ ഡയഗ്രാം ആയിട്ട് റെപ്രസെന്റ് ചെയ്യാന്ന് വെച്ചാൽ ഇറ്റ് ഇസ് used to represent sine wave in terms of its magnitude and its angular position. Okay, now we are going to consider only the magnitude and its angular position, and we draw a diagram that is known as Phasor diagram, and the Phasor diagram is represented on 4 quadrants. Okay, you know the 4 quadrants. Angle, that is here it is 0 degree, reference we taken on the 0 degree, this one 90 degree and 180 degree and 270 degree, and here it is again 360 degree. And we can represent the sinusoidal wave as a vector having a magnitude, a value, particular value. Okay, and there is an angle between this as marked as theta. Okay, so the position of a phasor at any instant can be expressed as either positive or negative. Positive or negative angle. That is, positive angle means that is leading. Leading angle is measured in anti-clockwise direction. If it is a waveform is a leading angle, so we mark it on anti-clockwise direction. If it is a negative, which is lagging. Okay, lagging wave is represented as negative. So lagging wave can be represented in as measured in clockwise direction from 0 degree. Okay, so if the waveform is lagging, then we mark the phasor or vector by measuring the angle in clockwise direction. If it is a leading vector, we measure that angle in anti-clockwise direction. For example, okay, first we are going to draw for an example one waveform, and that waveform we phasor ആയിട്ട് represent ചെയ്യാം. Okay, so first A is a reference wave. Okay, then second one B started from the 45 degree. Okay, 45 degree എന്നാണ്. അപ്പോൾ lagging wave ആണ് B എന്ന് പറയുന്ന ഒരു wave. Okay, അങ്ങനെ ഇരിക്കട്ടെ. Then C എന്ന് പറയുന്ന ഒരു leading wave ഞാൻ represent ചെയ്യാം. Another color. It is started from 30 degree. Here it is minus 30 degree എന്ന് start ചെയ്യുന്ന ഒരു wave ആണ്. That is okay. So the value, ഇനി ഓരോന്നിന്റെ value ഞാനൊന്ന് മാർക്ക് ചെയ്യാണ്. This is 50 volt. Okay, and this one is 70, and this one is 80. So this A, B, and this one is C. Okay, so there are 3 sinusoidal waveform. We are going to represent this as a phasor diagram. Okay, so I'm going to represent this on a phasor diagram. First one, we are going to represent A, vector A. How can we represent vector A? A is in phase with the reference wave. So we can draw the vector by another color. So this will be your A, vector A, and the magnitude is, what is the magnitude? It is 70. So represent the 70 volt with respect to that magnitude A, and which is in phase with the reference wave. And the second one, B. How can we represent B? B is a lagging with respect to reference wave. The waveform B is lagging by 45 degree. So 45 degree lagging ആണെന്ന് നമ്മൾ എങ്ങനെയാ മാർക്ക് ചെയ്യുക? We know that the lagging vector is represented in clockwise direction. So take a 45 degree in clockwise direction from the reference wave and mark the magnitude, that is 80 volt. That is B, vector B. Then take another vector, vector C. Vector C is a leading vector by an angle 30 degree. So minus 30 is represented on anti-clockwise direction and the magnitude is 50. So mark 50 volt, that is vector C. Okay, so we can represent this angle is 30 degree and this angle is, what is 45 degree. Okay, so we can say the phasor diagram can be used to represent the relation between the two or more sine waves of the same frequency. Okay, so we can represent either positive or leading wave or negative or lagging wave in a phasor diagram. Okay, so we can represent any waveform, sinusoidal waveform, as a vector or phasor representation. This representation is known as phasor diagram. Phasor diagram. Okay, that is the phasor diagram. So it is used to represent a sine wave in terms of its magnitude and its angular position. Okay, now we can represent a sinusoidal sinusoidal circuit, AC circuit, a simple AC circuit, that is phase relation in a pure resistor. So just consider a circuit which is connecting with a sinusoidal waveform. A simple resistor is connected across a voltage V and current is I. Okay, then the phase voltage equation can be represented as, at a particular voltage, it can be represented as V of t, an instantaneous voltage V of t. It can be represented as Vm sine omega t. If it is a sine wave, a sinusoidal AC voltage, Vm sine omega t എന്നാണ് നമ്മൾ represent ചെയ്യുക. Okay, voltage ആണ്. Current ആണെങ്കിലോ I of t is equal to Im sine omega t. Okay, so I of t is equal to Im sin. At any point on a sine wave represented by instantaneous value V of t, and it is equal to maximum value times the sine of angular frequency at that point. So an example പറയുകയാണെങ്കിൽ, the peak value of this voltage എന്ന് പറയുന്നത് V peak എന്ന് പറയുന്നത് 20 volt ആണെന്ന് എടുക്കുക. So what will be the instantaneous value at pi by 4 radians? Pi by 4 radians എന്തായിരിക്കും instantaneous value? You can find out it by V of t is equal to Vm sine omega t. So we can substitute 20 into sine pi by 4. What is sine pi by 4? That is 0.707. So 20 into 0.707. So we can get, that is 14.14 is the instantaneous value of that voltage at this particular instant. So you should remember one thing, when the sine wave is when the sine wave is represented, I don't think this, when the sine wave is represented as left to particular wave, this is the reference wave. When another wave is represented left to this wave, that means that waveform is a leading waveform. If a waveform is represented right to a reference wave, then that waveform is lagging waveform. You should remember that. Okay, so if it is a leading waveform, leading vector, so I'll again represent, this is our reference wave, and if the vector is leading, this is our waveform. This voltage is a leading voltage by an angle phi. How can we represent in an equation? V of t. This is our waveform voltage. V of t is equal to, we can represent that voltage as Vm sine omega t plus phi. Omega t plus phi. The reference wave is V of t is equal to Vm sine omega t. Okay, reference wave is Vm sine omega t, that is this A. For A, this is the equation, and for B, what will be the equation? This wave is leading waveform, so V of t is equal to Vm sine omega t plus phi. If it is a lagging voltage, represent. This is lagging voltage. This is our reference wave, and lagging voltages means a waveform which is lagging by an angle with respect to, that is, this is the phi angle. How can we represent the equation? V of t is equal to Vm sin omega t minus phi. Minus phi nanu represent. Okay, V of t is equal to Vm sin omega t minus phi. So this is the sine wave equations. Reference wave aanengil nammal V of t is equal to Vm sin omega t nanu represent. If it is current, I of t is equal to Im. I of t is equal to Im, maximum value of current into sin omega t. Okay, so lagging aanengil minus phi nanu kodukka, leading vector aanengil plus phi nanu mark cheyyam. Okay, thank you.